Okay, so we're going to do a video on multiplying fractions. The first thing you need to know is the rule. The rule to multiply fractions is you multiply straight across. So I'm going to show you an example of that right now. So we have the very simple fraction 1/2 times 2/3. So all we're going to do is literally just multiply straight across. So 1 times 2 is 2. 2 times 3 is 6. So you can see that this is an unsimplified equation or a fraction. So anytime moving forward, you're going to have to simplify all fractions. So we're going to go ahead and simplify this, and we're going to simplify it by dividing the top and bottom by the common factor of 2. So we're going to divide this by 2, and we're going to divide this by 2. So 2 divided by 2 is 1, and 6 divided by 2 is 3. And that is our final answer. Do another quick example. We're going to go 3. This is not showing up. Hold on. 3/4 times 2/3. Okay, so again, we just multiply straight across. Sorry for my pen. Multiply straight across. So 3 times 2 is 6, and 4 times 3 is 12. Okay, so again, we're dealing with an unsimplified equation, so we're going to have to simplify this, and we're going to simplify it by dividing the top and bottom by a common factor, the greatest common factor. So the greatest common factor between 6 and 12 is actually 6. So I'm going to divide this by 6, our numerator, and I'm going to divide the denominator by 6. So that's going to leave me with 6 divided by 6 is 1. All over 12 divided by 6 is 2. And that is our final answer. Okay, we have the same exact fractions we had. We had 3/4 times 2/3. So I'm going to show you another way which involves cross-canceling. And let me just write this down. This is called cross-canceling method. Okay, and it's similar to the method we already talked about, or the rule we already talked about, but instead of multiplying straight across, we're going to cross-cancel first, then multiply straight across. Then simplify. So just one extra step. And the reason why we do that is it kind of helps us, or it stops us from having to simplify in the end. So we have 3/4 times 2/3. So what I can do, I'm going to look at the numbers diagonal to each other. So 3 and 3 are diagonal to each other, and 4 and 2 are diagonal to each other. So I'm going to try to think of a number that can divide into 3 and into 3. Well, a number that can divide into 3 is 3. So I can divide this by 3, and I can divide this by 3. And then I'm going to think of a number that can divide into 4 and into 2 evenly. Well, 2 can divide into both 4 and 2 evenly, so I'm going to divide this by 2, and I'm going to divide this by 2. So that's going to leave me with 3 divided by 3 is 1. 4 divided by 2 is 2, times 2 divided by 2 is 1, and 3 divided by 3 is 1. Then I multiply straight across, just like we did before. Straight across. So 1 times 1 is 1. 2 times 1 is 2. So what it does is it prevents me from having to simplify too much in the end. It's just another method of multiplying. You don't have to use cross-canceling, but it does tend to be a little bit easier once you get the hang of it. Example, we have 4/5 times 2/6. So I'm going to look at the numbers diagonal to each other. So I have 4 and 6 are diagonal to each other, and I have 5 and 2 are diagonal to each other. So is there a number that can divide evenly into 4 and into 6? Well, definitely 2, right? Because they're both even. So I'm going to divide these two, 4 and 6, by 2. So I'm going to divide this by 2, and I'm going to divide this by 2. And then what about 5 and 2? Is there a number that can divide evenly between 5 and 2? Well, not really. 5's a prime and 2's a prime, and they don't share any common factors. So we're just going to go with what we have. So 4 divided by 2 is 2, and 5 stays the same, times 2 stays the same, and 6 divided by 2 is 3. Next, we're going to multiply straight across. So we are going to multiply straight across. So 2 divided by 2 is 4, and 5 times 3 is 15. And this is our final answer. So what this allowed us to do was simplify in the beginning so we didn't have to simplify too much at the end. And this comes in handy when we have pretty large numbers. In this case, it's, we could have simplified in the end. It wouldn't have been that big of a deal. But when you have very large numbers, it is helpful to do this cross-canceling.